resitting my high school. Resitting one of my high school math papers. I say resitting. I don't necessarily need to resit it. So we're going to be redoing my high school maths paper. And it should be a whole load of fun. For those who do not know, I do study maths at uni. Loved mathematics at high school. For those who do not know as well, I live in Scotland, and here in Scotland we have 3 levels of exams. We've got National 5, we've got Higher, and we've got Advanced Higher. And I did do maths at all 3 levels. But tonight we are going to be doing my National 5 maths paper. So, still somewhat complex things, but hopefully not too complex. So for those who might consider maths not their strong point, hopefully you can still enjoy this. Even if you don't like maths, hopefully you can still relax and enjoy the whispering and trying to solve numbers and things like that, whatever you want to say it. But if you guys do enjoy it, be sure to leave a like if you enjoyed this type of content, and don't forget to subscribe as well. We're on the grind for 15k subscribers, and the reason I'm doing this video is actually because I did a maths related video relatively recently, and you all seem to absolutely love it. So I thought, why not do another similar style video, and hopefully you guys will like it. So I'm going to be redoing one of my higher papers, my high school papers, sorry. We're doing my National 5 paper. This is actually the non-calculator paper. So at each level they do different papers depending on what level it is. And at National 5 they do, I believe, a 50-minute non-calculator paper, which is this one right here, as well as a 1 hour 30-minute calculator paper. So as you can imagine, this will have a lot of algebra, things like that involved, a little bit of geometry maybe. But it has been 4 years since I did this paper, so here's hoping we can still pass it. When I sat the paper at the time, I did get an A. Who knows, maybe I'll get full marks this time. I would hope so, considering I do study maths. But we'll see how we do. I'm gonna quickly switch on down the camera to my desk and we'll have a go at solving this paper. And I do also have with me some gum for some gum chewing sounds. So without further ado, hopefully you all enjoyed this, and let's jump straight into this paper. Alrighty guys, so here we go. I am super excited to sit this paper. You can see we've got this formulae list at the front, and there's quite a few questions. In fact, we can see that there are 12 questions in total. So hopefully we can get it all done in this video. And if you would like to see me attempt the calculator paper, or maybe some more complex papers, do let me know. I've got my pen, I've got my ruler. Who knows, we might need a ruler tonight. Let's click at this pen. And of course, I've got my chewing gum as well with me tonight. A bit contradictory, as they'd always tell you not to eat chewing gum or chew gum whilst in class. So this is not me setting a very good example, but oh well. Right, okay. So I've not had a look at this before. I may attempt some questions slightly different than you might attempt them, so let's get cracking. So we have total marks out of 40. And we are on question number 1 worth 2 marks. Given P, which is this vector 4 minus 6, a 2-dimensional vector, nice and easy, and Q, which is another 2-dimensional vector, minus 5 minus 1, find the resultant vector of half of P plus Q. Express your answer in component form. So component form is what this is in right here, so that's quite nice. So for this we are going to, sorry about that bit of background noise. So what we are going to do is initially work out what half of P is. So we're needing to work out half of P plus Q. So I'm gonna just put a little bullet point so they know we're just doing a little step here. So we know half of P. I'm gonna actually zoom this in a wee bit for you. So half of P is gonna be equal to, well, we're multiplying the vector P by a scalar of a half. So it's gonna be a half multiplied by the vector of 4 minus 6, which is just, well, divide each one by 2 just gives us 2 and minus 3, and we can then say that therefore a half of P plus Q is equal to, I guess these should have little arrows above them depending on how you do your notation. Half of P plus Q is going to be equal to 2 over minus 3 plus minus 5 minus 1. And I'm not sure if that's enough working, but you can pretty much see that that's going to be 2 minus 5, which is of course minus 3. And then minus 3 minus 1 is of course minus 4. I think that's probably all the working you need to do for that first question. So that's quite good. I think that would probably get us 2 marks, assuming I've made no mistakes. You can all let me know in the comments. I think you'd probably get a mark for working out half of P, and then another mark for working out what half of P plus Q is. So question number 2, which is a nice fractions question. We are asked to evaluate the fraction with multiplication and addition. 3/4 multiplied by a third plus 2 over 7. So I think probably the best way to do this is, I'm trying to think, for me, you should always do bid mass, so I think I'm gonna work out, you see it doesn't really make a difference. You know what, no, we're gonna do it. We're gonna start with the 3/4. So this here is going to be 3/4 multiplied by 1/3. I guess that's in brackets, and that's gonna be plus 3/4 times 2/7. So that's what we do there using our bid mass rules. And we can say that, well, we can do a bit of simplification here. We can just divide these both through by 3, divide these both through by 2. That's probably the simplest we can get. So here we're going to get 1 over 4. So 1/4 plus 3 over 14 by the looks of things. Yeah. But see, now we need to find a common denominator, which in our case is gonna be 28, I believe. So we can just set that to be over 28 plus over 28, yep. And this one here, to get 28, we are simply multiplying it by 7. So the top is going to be multiplied by 7 as well. This one's multiplied by 2, so we're going to have 6. So our final answer is going to be 13 over 28, I believe, and that is it in its simplest form. So that is question number 2 done. Moving on to question 3, here we go. I remember this question. I actually do, because I remember struggling to do this without using a calculator, which is quite funny, but we should be able to do it now. So the diagram shows a sector of a circle with center C. The radius of the circle is 20 centimeters, as we can clearly see, and angle ACB is 45 degrees, so this little angle in here, which is pretty nice, 45 degrees. Calculate the area of this sector, and it tells us there in bold to take pi as 3.14, which is pretty useful, considering that this looks like it is going to use pi to do with areas of circles, or sector of a circle in our case. Now, since this is part of a circle, we want to work out the fraction of what this is going to be of a circle. So I'm guessing initially we want to use the area of the circle, which is just going to be, of course, pi times the radius square. But then, because we're doing the area of the sector, I'm just going to denote it by a sub s. It's going to be a fraction of what this circle is going to be, which is 45 over 360 degrees in a circle, and then pi r squared, and we can just substitute our values in. So 45 over 360 simplifies to, what would that be, 1, 2, 3, 4, 8. So that's just 1/8. Pi for us is 3.14, and then the radius squared is multiplied by 20 squared. Very nice. And now it's just become this sort of numerical question. So I think what we'll do is we'll leave that 1/8 in, and leave that multiplied by 3.14, and just simplify it out a wee bit. This is going to give us 400. Quite nice. And then what we can do is 400 divided by 8 is just 50. Yep, 50, so that's pretty good. We've just got 50 multiplied by 3. That's a really bad 3. 3.14, which you can do in any way you want, really. The way I would do it is just times it by 10, which is 31.4, and then times it by 5. That's how I would do it. You can do it any way you want. I get 157. So our answer is going to be 157. And because it's an area, and we're talking in centimeters, it is going to be centimeters squared. I mean, hopefully that makes sense to you guys, how I worked that out. That is how I would do it. Quite a lot for only 3 marks. I don't know if that's maybe a strict marking scheme for that, but I'd maybe give like 4 marks for that. That was quite a lot for a question at Nat 5, I would say. Let's move on to question 4. Which is, it's a wordy one. Let's zoom in for this one then. Charlie, man like Charlie, is making costumes for a school show. One day he made 2 cloaks and 3 dresses. The total amount of material he used was 9.6 square meters. Write down an equation to illustrate this information. Okay, a pretty easy question. You can use whatever you want to denote a cloak and a dress. I'm just going to go with the first letters, C and D, and we're going to go with 2 of the cloaks plus 3 times however much it is to make a dress equals 9.6 square meters of material. Very easy, just 1 mark. You can kind of see where this question is going. It looks like it's going to use simultaneous equations. Question 2. The following day, Charlie made 3 cloaks and 4 dresses. The total amount of material he used this time was 13.3 square meters. Write down an equation to illustrate this information. Pretty much the same as the first question, but different numbers. This time we got 3 cloaks and 4 dresses, giving us 13.3. You might want to put somewhere like up here just a little side note that C equals cloak and D equals 1 dress. I don't know if they need you to do that, but I guess it's probably best to do that. And the last question, which I'm going to zoom out a bit for, is calculate the amount of material required to make 1 cloak and the amount of material required to make 1 dress. Okay, not too bad, pretty easy question. We've got 2 formulae that we just created. We kind of want to make these formulae easy to manipulate. Simultaneously, we can do some addition and multiplication to them. And to do this, we need to eliminate one of them. I'm going to go with the... Let's get rid of the C's first. Let's get rid of the cloaks. So what we're going to do is multiply the top formula. So I'm just going to denote this with a sub 1 like that, just so you can sort of see the link here. And the first one I'm going to multiply by -3, which will be apparent in a wee moment. So multiplying everything by -3, we get -6 on the top, -9, oh, -6C, sorry, -9D equals, and well, 10 times -3 is -30, and then we've got 0.4 times 3 is 1.2, so what's that going to be? -28.8, I believe. Yup. And then the second equation we're going to multiply by just 2, which is nice and easy this time. We've just got 6C plus 8D is equal to 26.6. And now all we gotta do is add these 2 together. Very nice. So we have -6C plus 6C, so that cancels them out. -8D -9D, sorry, plus 8D just gives us -D is equal to, that's going to be -2.2. So therefore D is equal to 2.2. So we can maybe say to the side of that, a dress is 2.2 meters squared. That's the first part done, isn't it? Well, that's material required to make 1 dress, so maybe underline that. Now we know a dress is 2.2 meters squared, so let's just say we're going to input D equals 2.2 into, what equation will be easier? I guess equation 1. And therefore, when we put this in, we're going to get 2C plus 3 times 2.2 is equal to 9.6, wasn't it? So hopefully this all makes sense. And then the last step is just to solve for C, which is of course a cloak. So D2C plus 6.6 is equal to 9.6. Subtract 6.6 from both sides. 2C equals 3, so C equals 3/2, or you can call it 1.5 meters squared, which is what we said up here. We used decimal up there, so it's good to make it consistent. So we can say cloak is, and then we'll just underline that. It's not the neatest working, but you can sort of see what we've done there to work both of them out. Hopefully things are going good so far. Okay, let's crack on with question number 5 up next. So far nothing too difficult, nothing too challenging. I guess at the end of the day, this is National 5, it's quite lower level maths, but hopefully you're all keeping along with it. So question number 5. Oh, it looks like a nice wee straight line question. I always love these. A cattle farmer records the weight of some of his calves. The scatter graph shows the relationship between the age, A, months, and the weight, W, kilograms, of the calves. So we got this little chart here, or graph, with the weight as the y-axis, the age as the x-axis, and the points of the calves, I guess, scattered amongst it. The line of best fit is drawn. Point D represents a 3-month-old calf which weighs 100 kilograms. So instantly I'm just gonna label this point 3 months old, so that's 3 on the X and 100 kg. I'm just gonna do that just to make it easier for me. And E is 15 months old, which weighs 340. That's a big boy. Alright, 15, 340. And we're asked to find the equation of the line of best fit in terms of A and W, and give the equation in its simplest form. Okay. This shouldn't be too bad. So we've got the point D, which was 100, and E, which was 15, 340. So to get the equation of a line of best fit, we need the gradient, and then we can use that gradient for a formula that I'll show you in a moment. So to get the gradient, we know gradient is just y2 take y1 over x2 take x1. That's a nice wee formula that you learn. Ry2 is 340 minus 100 over 15 minus 3. Pretty easy. This is 240 over 12, which is actually very nice because then it's just 20. So our gradient is 20. So that's going to be in front of the A, I believe. Eventually, we'll keep working on it and find out. So we've got this other formula that says y take b equals m. X subtract A. If you're wondering where I know this formula from, it's just something you learn quite early on in maths. It's a very, very famous and common straight line formula, I guess. And my A and my B are going to be, I'm going to go with these ones. I'm going to go with A and B. Now, of course, in our case, Y and X are W and A corresponding. So when we sub in all our values, this is actually going to be W minus 100 equals 20. A subtract 3. And now we just want to rearrange in terms of W, I guess. I mean, you can rearrange it any way you want for a straight line, but I'll just do it in terms of the y-axis. So this is going to be W minus 100. Let's expand the bracket first. 28, as I predicted, minus 60. So we get W is going to be equal to 28 plus 40 when we take the 100 over. So, not too difficult. Again, a fair bit of work in for just 3 marks. I don't know if that's maybe a bit strict. You can all let me know your thoughts, but not too difficult. Looks like this question's gonna have a part B to it. and I was not wrong. Use your equation from part A to estimate the weight of a 1-year-old calf. So what was it again? We had W equals 28 plus 40. Quite a nice formula. So we want a 1-year-old calf. So our age in our case is going to be 1 year. Now this is where they've tried to trick us, and they've put it in bold to remind us. We're talking about age in months. So our age is actually 12 months. So our A in this case is actually 12. So our W is going to be 20 times 12 plus 40, which is just, again, 240 plus 40, which is 280. And this is, we're working at the weight, it's in kilograms as it said. So there's our answer, 280 kilograms. And we're now on to question 6, which is it's a graph and a function question. That's quite nice. Specifically, we are determining the nature of some roots. And, well, for those who do not know, when working at the roots of a function, you just want to use the discriminant from the quadratic formula. And the discriminant is the b squared minus 4ac section. And I will just put like in a little curly bracket here that our a is equivalent to 7, our b is 5, and our c is minus 1. Just to make it easier to see. So we sub in our values, we're going to have 5 squared. We're going to have minus, and this is 4 times 7 times minus 1. I'll just put a wee equals there, so this is going to be 25 minus, let's see, it's going to be 28 minus 28. I'll just keep it in brackets for the now. So this is very important you get your signs right here, because it will affect your answer. So for us, we get 53. And one of the facts you learn that if your discriminant is greater than 0, the roots are called real. I'll put it in bold. And I don't know if they want you to put this too. Oops, distinct. They're the two things that we probably want to say if I spell distinct right. I don't know if you need to give a reason, but we can just say, since discriminant is greater than 0. I don't know if you need to give a reason, but probably best to. Next up, another very big geometry question. The diagram shows a rectangular based pyramid relative to the coordinate axis. A is the point 2, 0, 0, V is 5, 2, 6, which is up there. Write in the coordinates of B. You could honestly do this question if you don't even do maths. You can kind of just work it out. So I'm guessing this is in terms of X, Y, Z. I'm just going to write that so I don't get confused, or maybe to help you guys. So if A has gone along 2, and to get to the middle point of this sort of bit for Y, we go along 3. So each side of this rectangular base, well, this side anyways, is going to be 2 times of 3, so it's going to be 6, and I'm going to label that. So, in fact, you know what I'm going to do? We're going to put A is 2, 0, 0, and what we want to do is add 6 to the X. The Y is going to go back, well, 2 times whatever this goes back, so that's 2. So it's going to go back 2 and then back another 2, so it's going to go plus 4. and said, well, it doesn't go up at all, so that's going to be plus 0. So we can then say the b is going to be 8, 4, and 0. Again, I hope that makes sense. That was I worked through that very quick. It's sort of just logic, the way you sort of work that out. But 840 seems to be right, and I'm going to pop it up here as well. Just to help our diagram a wee bit. So what's part B saying? Calculate the length of the edge AV. Oh, okay, so that's this weird sort of edge that goes up here. So this is where we use a bit of Pythagoras, I guess. We've got a few triangles we can make. We've got this A to V, V to the middle, and then this little triangle here. But then we need to use this little triangle in here. Sorry about this background noise. Okay, I do apologize about that. Where were we? Okay, yeah. So, looks like we need to use a bit of Pythagoras. We need to first work out what this little edge here is, because we know that from here to here it is 6 along the z-axis. So we can kind of make two triangles to do this, because we're working out AV. So the resultant triangle that we want looks a little something like this, where this is A, this is V, this is the length we want. We know this is right angled as it tells us. We know this is 6, but we want to work out this here. I'm going to label this, let's just call it, I don't know, let's just call it C, I don't know, random letter. So we want to work out what AC is. And to work out this, we might need to use the facts we know from this triangle here. So we have a second triangle, which I'm gonna, again, try and draw, which does make a right angle. And we know it is because it is two lines that are perpendicular, crossing each other right there. And this line is 3 right angled. This line here we said earlier is 2. So we can use Pythagoras to work out what this is. So we'll call this just x. And we know from our Pythagorean formula that x squared is going to be 3 squared plus 2 squared. So x squared is going to be 9 plus 4, which is 13. So x is therefore a bit of an awkward number, but root 13. I think I'll just leave it like that, because we're going to have to square it here. So we know that AC is going to be root 13. And then we can just do it again. We can say that AV squared is going to be 6 squared plus, and here's where this square root just disappears, because 13 squared, the square root of 13 squared just gets rid of that, so it's just 13. So that's going to be 36 plus 13, which is what? AV squared is equal to 49. Therefore, AV is the square root of 49, which is perfectly 7. And there is no units. So AV is the length 7, which seems about right. So I'm pretty sure we've done that question correctly. Coming towards the end of the paper here, we have a little bit of algebra here. Solve the equation. Okay, so it looks like we just need to solve for x by the looks of things. So we've got this formula here. We probably want to get rid of these fractions, and the best way to do that would probably be to multiply each factor through, or each thing, by 6. 12x over 3 minus 30 over 6 equals 12x. Yup, and then we can just simplify these. 12x over 3 is just 4x. 30 over 6 is just minus 5 equals 12x. Nice and easy. Subtract 4x from both sides, we get minus 5 is equal to 8x. Therefore, x is equal to minus 5/8. Again, a pretty weird answer, but it seems right to me, so there's no reason to think that it's not right. And we'll move on to question number 9. The function f of x is defined by f of x is 2 divided by root x, where x is strictly greater than 0. Express f of 5 as a fraction with a rational denominator. So for those who do not know what a rational denominator, that basically means there's no surd on the bottom part of the fraction. So let's start by working out what f of 5 is. That's probably where you get this first mark. So it's just going to be 2 over root 5. Very easy. And then to rationalize the denominator, we just multiply both top and bottom by root 5. Technically that's a fraction like that, but you can just do what you want. So therefore f of 5 is going to be 2 root 5. And then root 5 times by root 5 is, of course, just 5. So we've got 2 root 5 over 5. A very easy combination of questions on this side of the page. Nice marks there. Let's move on to the next side. So next up we've got, it's a sketching question, so my ruler is finally taking into action here. Sketch the graph of y equals x minus 3 squared plus 1. And on our sketch we are asked to clearly show the coordinates of the turning point and the point of intersection with the y-axis. It doesn't ask for the intersection of the x-axis, and well, I actually know it doesn't cross the x-axis, and the way we can do that is as follows. So the turning point, for those who don't know, if you have it in this form, all you gotta do is change the value of this here. So if it's a minus 3, it becomes a 3. So our turning point is going to be 3 and then 1. It's just a fun fact that you kind of just pick up. It's just how you'd observe it. And if it turns at 3, 1, it's not going to cross the x-axis, because this is going to be a graph that looks like this, basically. Obviously not that pointy at the bottom, but it's going to look like that. And we want to work out our intersection with the y-axis. So let's work out what this formula is when we expand it. So we're going to get y equals x squared. We're going to get minus 3x minus 6x plus 9, then plus 1, which is plus 10. And that just proves, because this is a positive x, that is what our graph looks like. And to work out where it crosses the y-axis, well, when it crosses the y-axis, x is always going to be 0. So we just sub in x equals 0 into this, so we get 0 squared minus 6 lots of 0 plus 10 just gives us that our y-intersect is going to be at 10. So we'll put y int is going to be 0, 10. Pretty nice. And then here comes my awful graph sketching skills. You don't have to do a good graph as long as you've got a ruler, and again, you just show the turning point, and where it intersects the y-axis, you're all good. So let's just call this point here 10. So that's that's where it's going to cross, we can honestly just draw it and then just say the points are what they are. So it's going to look like that. We can just label this 3, 1. Call this our y-axis, call this our x-axis, maybe add a little 0 there. And we're all good. Not a bad sketch, actually. Let's move on to question 11. Which is, oh wow, okay. We got a bit of trigonometry. Was not expecting that. I don't really remember this question. But we're asked to simplify tan squared x, cos squared x. Do marks. Oh, I know. So, basically, one of the things you learn when doing maths in high school is that tan is the same as, and I think almost everybody that does maths will probably know tan is just equal to sine x over cos x. So therefore, tan squared x is just going to be sine squared x over cos squared x. This is just my little working at the side, by the way. So if we want tan squared x, cos squared x, to get that on this little bit here that we've got, we just multiply both sides by cos squared x, right? And we get tan squared x, cos squared x equals sine squared x. So we literally have just done the working there. I probably should have moved it over, but we've showed that this simplifies to sine squared x. And I know that seems all over the place. This is all my working here. That probably gets you 1 mark. That bit there, and then 1 mark for that bit there. But yeah, it's difficult to explain these things. They're kind of just little identities that you learn. That's the way I would have done that question. There might be other ways, there probably are. But that makes the most sense that way. But anyway, we move on to the last question, and this question looks absolutely amazing straight off the bat. Love me some geometry, love me some algebra. The diagrams below show a rectangle and a triangle. All measurements are in centimeters. Probably important, we might ask to find a length eventually. We've got the diagrams below. Find an expression for the area of the rectangle. Well, I think everybody knows that the area of a rectangle is just the length times the breadth. And in our case, the area of the rectangle, I did this earlier, by the way, this little sub R just means rectangle. The A obviously being area. Should probably be a capital A, I'm not too sure. So our length, we're just gonna go with, let's call it x plus 8. And our breadth is 2x plus 1. And I'd probably leave it like that. I doubt you need to expand it. That is, of course, its simplest form, so that's the area of the rectangle. Given that the area of the rectangle, this thing here, is equal to the area of the triangle, show that x squared minus 2x minus 8 is equal to 0. Okay, so I guess we've got to show that this thing is equal to the area of this. So, well, for starters, we know that the area of a triangle is a half base times height, which in our case is a half. The base is times 2, sorry, that just means times 2x plus 5 times 3x. And that's nice because that just cancels out. So we got 3x times by this bit, which is of course 3x squared plus 15x. So that's the area of our triangle. And that is equal to that. So we just want to set them equal to each other, right? So we say 3x squared plus 15x is equal to x plus 8. I might run out of space here, but we'll give it a go. 2x plus 1. And then we simply just want to expand and try and get this equation essentially. So let's just do that. When we expand this, we're going to get 2x squared. We're going to get, I'm trying to do this all in one step, 16x plus 1x, which is 17x. And then plus 8. And we want to rearrange, so we get 0 on one side. So let's take everything over here. Minus 2x from both sides, we get x squared. That's the first thing, so it looks good. 15x minus 17x is minus 2x, which is the second thing that's good. And then we have 0 minus 8, which is, of course, minus 8. And there we go, we have shown. I guess this is kind of a proof. Where I go to uni, we would do this little thing here to show that we've done the proof. Right. Last question of the night. Hence, find algebraically the length and breadth of the rectangle. Okay, right, so that's the area of the rectangle, essentially, isn't it? Let's see. Hence, find algebraically the length and breadth of the rectangle. Yeah, right. So we're gonna take our formula. What was it? X squared minus 2x minus 8 equals 0, and we just want to find the values for x. Right? I guess we could do it for any of these formulae. We could do it for that formula, we could do it for that formula. But I'll just do it for this one because it looks quite easy. And we're just going to simplify it by putting it in brackets to solve for x. So we're going to have 8 at the start. We're trying to make minus 2 with 8 factors of 8. So we've got 4 and 2. Yeah, we're going to have minus 4 plus 2. So therefore, we can deduce that either x equals 4 or x equals minus 2. Now in our case, x is going to be 4 because you can't get a negative length. You can't go back 2 meters. You always go 2 or 4 meters. So in our case, our x is 4 because it cannot be negative 2. So the length of the rectangle we said was x plus 8, which is of course 4 plus 8. I'll just do all the work in, which is 12. Remember, it's centimeters. And the breadth of the rectangle we said was 2x plus 1. Yep. 2x plus 1. Substitute, it doesn't really need to be in brackets, but substituting that in, we get 2 times 4 plus 1, which is just 9 centimeters, and that is our length and breadth. And that brings the paper to an end. Well, that was so much fun. Hopefully I nailed it. You guys can compare the answers that I got with what you got if you did want to try along. I'm hoping I made no mistakes, but who knows, maybe I did. We'll have to check back and see if I got full marks. But I'm guessing I probably did. Nothing was too difficult. So if you all did enjoy this, be sure to leave a like. Let me know in the comments if you want to see another one of these. I could maybe do a different paper. I also did physics. Maybe we could do a physics paper. That would be quite fun. But yeah, thank you all so much for watching, and I will see you all in the next video. Good night, guys. Thanks